Everything's perfect. Okay. Yeah. Hello, hello. Is it flickering again a bit? Should be come back soon. Perfect. Welcome everyone to top new CNCF projects to look out for. The screen seems to be flickering a tiny bit sometimes, but no worries, it has come back every single time when it has happened. So let's not panic too much about it. But very much welcome to my session. It's always great to have so many people here. Really looking forward to this session with you guys today. So let's get right into it. So the topic is very interesting, but what value do you actually get by attending this talk? I usually try to make it kind of clear in the beginning so that you understand what are the, I don't want to say learning goals per se, but like what will you learn, what will you get out of this session by listening to it? So the value that you get essentially is, we wait for the screen, you get to inspired, hopefully, you get to hear about cool new CNCF projects, and that's where the inspiration comes from. So my session isn't really, step by step, do this or that. It's more of a, hear about projects, learn more about a bit about them so that you can get inspired and then dig deeper yourself into more of them. I cover quite many projects in a relatively short amount of time, so that's exactly why this is built this way. So then who am I and why am I here talking about these topics? So I'm Annie, and I'm a senior product marketing manager at Kamunda. I am also a CNCF ambassador as well as an Azure MVP. I'm also been organizing the Kubernetes and CNCF meetup for Finland for over 4 years now. And in addition to that, I am a startup coach. So I coach early stage startups, as well as I am a co-host and co-producer of the Cloud Gossip podcast. So what all of this means, I'm super excited about Kubernetes and cloud native tech, and I love speaking about it as well. So that's, I think, me in a nutshell. So if you are not familiar with CNCF, how many of has heard about CNCF before this session? Perfect. A few of you, but no worries. Here I am explaining what it is if you are not familiar with it, yes. So I try to aim the session so that everyone gets something out of it. Even if you had never heard about CNCF, you learn something. And if you are relatively deep into there, you will also get something out of from this session. So CNCF is Cloud Native Computing Foundation, which is building sustainable ecosystems for cloud native software. So the Cloud Native Computing Foundation, it is under Linux Foundation, which is a nonprofit, and it also organizes events like KubeCon, so one of the largest open source conferences in the world. But the most important and the main part here is that it hosts critical components of the global technology infrastructure. And what does that mean? It's home to Kubernetes, for example, or Prometheus, and multiple other projects. So it is the organization behind fostering and helping these open source projects grow, as well as helping the maintainers grow and have a good project management experience, of course. Now that we get to the next slide, we see that impact of cloud native is really widespread in the world. So CNCF does this survey every year where they ask cloud native landscape people, how do they use Kubernetes? What are the challenges? What are the kind of adoption level and so forth? And the latest one was in 2020. And in there, we already just see what everyone, I think, in the software world kind of notices is the impact of cloud native and containers is big. So the use of containers in production has increased to 92%, up from 84%. Up 300% from the first CNCF survey in 2016. And Kubernetes use in production has increased to 83%, up from 78% last year. So it definitely is growing, even though it's big, and it's here to stay for sure. So if you're wondering how does the CNCF, the cloud native landscape look like, it looks like this. And it's quite a lot to take in for the first time. That is the natural and the correct reaction is to be, that's too much, like too many details, too many everything kind of. Obviously, it's a good thing that there's a lot of things happening in the scene, but at the same time, it's really difficult to comprehend this kind of image. And you could talk about just an area of this image for days. So this session aims to simplify this a bit and get you started understanding this landscape as well a bit easier. Then we wait for the flickering to stop, and then we get back to the screen, which shows us that there is actually like a simplified view. You can think about that. Well, it's a fact that the CNCF projects go through 3 stages in their life cycle. So when a project enters CNCF, it usually happens in the sandbox phase. It could happen in some other phase as well, but if it's a sandbox phase, it is very early on. It might have few maintainers, X amount of users, and so forth. But when it matures, it gets more people behind it, more committers, more maintainers, more companies using it, more end users. It will move on to the incubating phase, and then finally, when it matures more and more, it moves on to the graduated phase. And just to give you an idea on how many projects are there kind of these categories, there's about 50-ish, 60-ish in the sandbox phase. There's about 20 to 30 in the incubating phase, and about 15 have graduated fully. So then they are fully mature, ready for full production and so forth. Another way to look at it is this handy image, where, as you can see, at the sandbox phase, the project is utilized by innovators, techies. Then at the incubating phase, it's for early adopters, kind of visionaries. And then when you get to the graduated phase, you are already adopted by early majority or even the late majority. So that's how the kind of life cycle of a CNCF project works. Then if we get to the next slide, eventually we will know about so there are multiple projects in this session. This is not a scientific method that I've selected these. It's more of a curated list where people that I know are excited about a project. I'm excited about the projects. I've heard meetups people are talking about it, because I think that's a really great way to determine if an open source project will be successful as well, because it's an open source project. It lives and breathes on the maintainers and the committers around it. So you need to have a functional community that's actually excited about building the product. So this is one of the main criteria that I use. But other than this list that I have, there's obviously many wonderful CNCF projects as well. But just to, I couldn't talk about 100 projects here in 45 minutes. It would be crazy. So we got to select some. And as an expectation, usually CNCF, they have this introduction to project talks, for example, in KubeCon, and they are usually 30 to 45 minutes in length per project. And I'm going to cover multiple projects within a 45-minute session. So obviously the math there makes you already understand that this is not going to be a deep dive into any of the projects. It will be more of a look into multiple ones. And then I will give you resources in the end where you can use to then do your deep dive on your own on the projects that seem most fitting to your needs. So I'll be covering Linkerd, Keda, Flux, Kudo, and Meshery. And I've also added Helm as a graduated it's not a super new project. It's not new much, but it's a very strong one. So if you are not familiar with the Kubernetes and cloud native landscape, it's a great place to start with adopting a CNCF project as well. So let's get kicking with Helm then. So Helm is the package manager for Kubernetes, and Helm is the best way to find, share, and use software built for Kubernetes. So Helm is a graduated project, so I'll start with the graduated projects and then move to the incubating and then finish off with the really new sandbox projects towards the end. So how many of here has used Helm actually? Okay, perfect, a few of you. But good that we have some Helm beginners as well. That's really nice. So Helm is package manager for Kubernetes. So it's similar to Homebrew, Snack, or Chocolatey, but just for Kubernetes. And I think one of the Helm maintainers said it really well. So Helm is package management, which is tooling that enables someone who has knowledge of an application and a platform to package up an application so that someone else who has neither extensive knowledge of the application or the way that it needs to run on the platform, so that they can use it as well. So this is really the power of package management, and therefore the power of Helm as well. So Helm helps you manage complexity. It helps you with easy updates. It has simple sharing and rollbacks. So what does these things mean? So the charts in Helm describe even the most complex apps, as well as help with provide repeatable application installation and serve as a single point of authority. And the updates obviously take the pain out of updates, so you can use in-place upgrades and custom hooks. And charts are easy to version share and host on public or private servers, as well as you can use Helm to roll back to an older version of a release with ease. So what are then the principles? How is Helm kind of built? So Helm takes security very seriously. It can be recommended for public deployment. Helm has multiple maintainers, multiple companies backing it. As mentioned, it is a graduated project, so it's very mature, a very later stage project. It has power user email lists, release candidates, all the fun stuff. It supports Mac, Linux, and Windows, and it passed 1 million downloads a month already in 2019. And Helm is used by using charts, and the prerequisites are simply to have a Kubernetes cluster, deciding what security configurations to apply to your installation, if any, and then installing and configuring Helm. So it's very straightforward as far as these things go. And then as a bonus project that I didn't also mention in the beginning, Artifact Hub, which is a sandbox project. So it's one of the most earlier stage projects. It's a really great way to find Helm charts, for example, easily. So you can find and install and publish Kubernetes packages there. So it used to be so that in the past, Helm had its own place for artifacts, so Helm Hub, where you could find charts. But then it's really easy for the end user experience to become very scattered if every single CNCF project has their own Artifact Hub and everyone's just kind of trying to, reinvent the wheel. So rather than that, Artifact Hub was created to become the number concentrated place for all of these Artifact Hubs, which is Artifact Hub. So that's really nice. And then I have a quick Helm demo to run through. Let's switch to my gazillion amount of terminals here, because I have 3 demos up and coming within this session. Yes, let's get started. So the demo is about how to deploy a complex application, so such as WordPress, for example, in this case, as an example, let's put that in the beginning. There we go. So how you can do it way faster and more efficiently. So if I'm going to do AZ account show, yes, it's all working really well. I am logged into Azure and everything is working as it should be. And then kubectl get services will show us do we have any Kubernetes clusters running, and there we have the cluster that I've created before. And then let's do kubectl get services all namespaces, which is actually going to let us see a bit further, because in there you can see that it's an empty Kubernetes cluster. But if we do this, we can actually see into the other namespaces. So we see that there's actually a little Linkerd stuff there, because there's a Linkerd demo coming up as well. But then if we do Helm Wist, just to further prove to you that no, it's not, nothing's there, it's empty, so we're doing it from scratch. So there is no Helm releases either there. So now we need to add the bitnami. So then we would click Helm repo add bitnami. But for me, I've done it before, since I've done this demo before. For you, it would do more stuff there. So then if we do Helm search repo WordPress, this is where we see the Helm charts that are available. And we will be using the bitnami one as mentioned before. And then if we do Helm install bitnami WordPress generate name, we will then start to the actual action. So before that, I was just showing you that everything was empty, everything was clean, but now we get to the majority of the demo actually. So in here we see a lot of stuff happened, and then we're actually now already kicking off with our generation of the WordPress. So then to just further validate this, that it actually happened, we can do kubectl get services again, and instead of an empty cluster, now that we see that there is an external IP available for our WordPress, It's not gonna be ready quite yet, but it will be quite soon. So we're gonna put that to here too. Let's maybe use this one. This here, so that when it springs up, it's already ready there. And I don't have to copy paste it again. So while we wait for that to spring up, we actually have some things to do, because we have the WordPress now, kind of, it's being generated, it's all good, but we do want to actually access this as well. So we don't just, wanna have it and look at it. We actually want to, write our blog, or want to just use it in general. So we see the username there. So it's just user. And to get the password, we can just copy paste this, because it's stored as a Kubernetes secret. So we put this here. Oh, no, it copy pasted more. There. No, I'm just still copy pasting too much. I have sometimes issues with typos and everything. Why is it making that weird? That's very strange. Oh no, there it is. I think I'm like having issues with my but yeah, so then we can click this to right here. So we have the password there. Done. So now we have actually, here it is, the WordPress is already up and running relatively fast, I would say. So all in all, we've installed WordPress and MariaDB to our Kubernetes cluster, configured WordPress, and stored the admin credentials securely as Kubernetes secrets. So now if I find my mouse and we can get here, we can then actually try to go to use that password that we just generated. So we put your user here. And then if I did everything correct, yes, perfect. So then in here we have the WordPress up and running, we have the dashboard, we could start, creating new things here as we go. So I would say that it's quite easy and quite fast to go quite far with Helm already. Perfect. So since we are on the clock, obviously, let's get to the next project, which is Linkerd, which is a service mesh. It's a very recently graduated project, but it was an incubating project for quite a while, but then now it's graduated. How many here has used Linkerd before? Okay, that's great. One person or maybe two. But no worries, then we're gonna be hearing about Linkerd now. So Linkerd is a service mesh. It's ultra light, ultra fast, and security first service mesh for Kubernetes. So it is similar to Istio, just a bit of different features and whatnot, but it is the first service mesh around. The overall goal is to reduce mental overhead of having a service mesh at all. And it provides observability, reliability, and security. So what are then the benefits of Linkerd? So it has a really thriving open source community. There's a lot of community material around it, tutorials, learning, so you can really kind of get yourself quite far with Linkerd. It has a simple and minimalist design. It requires no complex APIs or configuration. So for most applications, Linkerd will just kind of work out of the box. And it provides deep runtime diagnostics. So you can get a comprehensive suite of diagnostics tools, including automatic service dependency maps and live traffic samples. As mentioned, it's ultra light and ultra fast. So it's built in Rust, and it has very small data plane proxies, as well as they are very fast. And it installs in seconds with zero configuration. And it installs into a single namespace that we actually already saw earlier. And it has actionable service metrics. So it provides those observability metrics, so you can monitor success rate, request volume, and latency really easily as well. So that's most of it. And then also Linkerd has its own custom proxy, which is Linkerd 2 proxy, so which means that it's built around very kind of custom and heavy focused on Kubernetes focus as well. So a lot of CNCF projects use Envoy, which is another project, but Linkerd has built its own. And really the principles are there just to, like, it works, it's light, it's simple, and it's security first. So it's kind of very bare minimum, but then again, it's also very easy to start using them at the same time. I'm going in the wrong direction. So then, like, further explaining about the simpleness, so what's needed to use Linkerd, you can just use it with just injecting this, and that's it. So then I have a Linkerd demo as well, which is easy real-time service metrics. just like an example application from Linkerd that shows you how does it look like and how does it feel like to use Linkerd. So let's pop to here and do this so that we can actually get to the application itself. So there we see if the Wi-Fi permits, we will get to our app that we will be kind of now soon seeing the metrics from. So how does this kind of app work? So we see, okay, here's it's emoji voter. You have a lot of emojis there. So we can, vote for the one with the mask. You pick this. We can pick another one. We can pick the girl here. And then if we click on the view leaderboard, we can see the leaderboard of emojis, which emoji has received most votes. And in here you can see that there's quite a lot more votes than what I just gave. I gave 2, and then there's a gazillion votes for these. So there's a lot of bots voting on the background. So this then obviously gives us the ability to see into what's happening within here. So we can do it with Linkerd emoji with the top display. And here we start to see the bots voting in the background, which is just a really simple command as well. And then if we want to see what's happening inside a single pod, we can grab a hold of another one and do this. So then we see even more info. And then if we want to kind of maybe the most easiest to approach version of all of this, we, for example, grab the blue one and we do Linkerd dashboard. And then it opens up a nice dashboard where we can see actually quite a lot of info in a nice way. So we see the success rate, we see the latency, and so forth. And then some of the same data that I just showed, we can go here and we can do emoji voto and then start. And then we see more of a graphical representation of all of these things. And then if we go here and then we actually click on the Grafana logo there, we will actually get to Prometheus to see even more data there. If the internet works fast. It's always the nervous part of a demo, but we've already seen most of the stuff. So if it's very slow at opening it up, we can kind of skip to the next thing as well. But it should be like we can see it racing there, getting to the finish line. But maybe it's going to take a bit too long. Let's see. Now we're making it there. So in here we see even more. So we see the global success rate, deployments monitored, a lot of nice graphs already here as well. So that's it for the Linkerd. So then let's maybe close this one, for example. So, and as we are here, we're gonna hop on to the next project, which is Keda. So Keda is an incubating project, and it's actually very recently incubating. So it was a sandbox project for a while, and now I think couple months ago during the summer, spring-ish max, it became a incubating project. So what is Keda then? Keda really kind of goes into serverless, so it really allows you to focus on your code. It's about event-driven code and scaling and on-demand compute and pay-per-use. So default Kubernetes scaling is not really well suited for event-driven applications. Kubernetes is more for resource-based scaling, so CPU and memory. How many of here has actually heard about Keda? I forgot to ask. Okay, perfect. So, as this is the situation, so Keda then here comes into play. So it's event-driven scale controlling that can run inside any Kubernetes cluster. So it means that it can monitor the rate of the events to preemptively act before the CPU is even affected. So you can install it into new or existing clusters, and you can use extensible and pluggable scalers to grab metrics from multiple sources as well. I will have a Keda demo as well to showcase a bit further. So what are the Keda principles then? So Keda is about not rebuilding anything that Kubernetes offers out of the box. So it has to be something new. And then it's single purpose, simple and non-intrusive. And it works with any container on any workload. And then the Keda demo will be about scaling .NET Core Worker with Azure Service Bus. And you can see the architecture there. So it's very abstract with just, order portal, order processor, and so forth. But what this essentially just is let me take order. This is you can imagine it as I even imagine it's a web shop. So if you are running a web shop and you're kind of thinking that, okay, I might get a rush of orders at some play, Black Friday, Christmas, any of the holidays, for example, when people might be just rushing in to order a lot of things. So then we need to scale up and we need to scale down to handle all of those orders at the same time. So that's what this demo will be about. So let's get to this is going to be the last demo of today. So we managed to do 2 out of 3 without any huge hiccups. So let's keep our fingers crossed for the last one to do nicely as well. And then actually let's just clean house a bit here so that we get to have a bit of a easier clean slate, not be I hate when all of those error messages coming, even though, it's fine that my demo application is sending errors, but, it's just nerve-wracking to see. So I'm going to switch to different cluster so that we can actually get to this demo as well. So let's get started. Then first I'm going to open up a few terminals and show you some things. So with this, we're going to actually see when the orders start coming in. We want to actually put this. Okay, let's maybe use actually this one. There we go. Let's put that there. So in here, as you can see, it's Keda samples order portal. Let's put it a bit here. Then let's open. Let's do this one. This seems good. Just a bit of housekeeping so that we can see a bit better. There. And then let's open the last one so that we have even better visibility. There we go. Now we are ready. So then we have the Keda samples order portal where we will see the peak of the orders come in. And then if we do this, which is Keda get deployments here, we can see here how many order processors we have ready. And I have to do a lot of this preparation because when the demo actually starts, it's going to be super fast because it's just going to be a lot of rush orders in at the same time. So then, it's good to be prepared. So then to get even more visibility into the past, what's happening, we do kubectl get pods into this one. And then now we get to the actual action in the demo. So hold on to your hats because it's going to be relatively fast. So we're going to do this here, and then it's going to actually ask us, let's queue some orders. How many do you want? So this is now the rush of orders coming in. Let's do 100. So there's a mouse for Lily, a bacon, keyboard, towel, so many. It's coming also fast. And then now we see this is kicking in. So the orders are peaking, and we see here actually that it's going to soon start kicking off more order processors. So now it peaked to 100. So we now see that there's was a pending, it's containers creating, and then it's running. And then in here we see that we are already 4 out of 4 of order processors in use. And in here we start seeing that it peaked at 100, but now it's actually going to start going down. And then in here we are getting away from, kind of just pending and container creating. We are getting to running phase here as well. And we are now 8 out of 8 in here of order processors in use. And as you can see, we are running through that order queue. So we have scaled successfully. We are at 10 out of 10. Soon now order queue is empty. 10 out of 10 order processors here, and it's just running and everything went really smoothly. We auto scaled up as we should have, and then now Keda will also eventually start to scale us down. So because there's no longer orders coming in, obviously, at the moment, so we have handled them. So this is really where Keda shines in wonderfully. And obviously this is great for management perspective, as well as from cost management perspective, as well as from environmental perspective, because if you are auto scaling when there's a need and then down scaling when you don't need the order processors, you are being very wise with your use of resources, both for monetary as well as obviously environmental purposes as well, which is really nice. So eventually the termination of the order processors will happen, but it's going to take about 5 minutes, and we have more projects to cover. So we're going to leave that there. And I can, if I remember towards the end, we can just check. But it's just going to say like order processors terminated, and that's it. So nothing too fancy, even though it's cool to see, at least in my opinion. I think it's nice. Well, yeah, let's hop on to the next project then. So we have Flux. So how many of you have heard about Flux? Perfect. So let's jump right into Flux, which is the GitOps family of projects. So Flux is, it really goes into like, first off, what is GitOps? So you have all of these CLI tools, so kubectl update, kubectl set image, Helm upgrade, kubectl upgrade. You can all of these replace with just one CLI tool, which is the most well-known one, which is Git. So Git push. So instead of changing the state of your cluster with multiple things, you can use one command. You can modify something, you can push it to your Git repository, and therefore it will just end up in the cluster as well. So this can be anything from namespace. So another reason why this is really great is that if you use Git, you have a nice history of what's happened to your cluster. So GitOps really provides you one model for making infrastructure, apps, and Kubernetes add-on changes, and you have a consistent end-to-end workflow across your entire organization. So in a nutshell, what this does is that you have an easy snapshot of your cluster that you can restore back to. So if anything happens, if you lose a cluster, you just plug your new cluster to Flux, and you restore everything. So it's not going to restore stateful sets or databases, all of these things, but everything that was in the Kubernetes memory, it's essentially restored. So to simplify things, it's kind of like a desired state that's saved in Git. So it's not the actual thing, but the desired state. So kind of like a save point, you can think about it. But then why is Flux great for GitOps? So Flux aims to provide a complete continuous delivery platform on top of Kubernetes, supporting all of the common practices and tooling in the field, so customize Helm metrics with Prometheus and so forth. And Flux itself, even though it is a incubating project, it is still actually rather recommended already for deployment and use. So CNCF has this kind of thing, which is CNCF technology radar that's looking into what technology should everyone be kind of adopting if they need that, and Flux is already recommended by that as well. So what are then the Flux practices and benefits? So it's helped define GitOps practices, so it describes your system declaratively. It keeps configuration under source control, and you can use software agents to reconcile and ensure correctness and alert for drift as well. So it has a lot of great benefits from collaboration on infra, access control, auditable history, drift correction, clear boundaries between dev team and Kubernetes as well. So that's Flux. So then let's go to the first sandbox project of today, which is Keda, which is the Kubernetes Universal Declarative Operator. So as always, now that I have a chance, that it's not a virtual audience, I can ask you guys, how many of you have heard about Keda before? Okay, this is good. But it's a sandbox one, so it's a lot less well known as well. So that's great that I'm introducing new projects. So Keda then is, as mentioned, the sandbox project, so it's more early stage. And Keda really goes into the kind of statefulness versus stateful app. So if all apps were stateless, everything would be really simple, but not all apps are stateless. So stateful apps need logic, specific knowledge to run a certain application. So Kafka might differ from Cassandra and so forth. And Kubernetes has been very focused on stateless, and stateful apps do not really play well together with it. So for this, Kubernetes created stateful sets, but it does not really, then stateful sets do not really solve the fundamental issue. So the solution there has been operators so far. So what are operators, if you're wondering? So operator manages and monitors the lifecycle. But it requires a lot of custom knowledge to build an operator. So the main thing really is that each operator is unique and it's purpose-built for each application. So it requires deep expertise and may require thousands of lines of code just to build an operator. So a substantial engineering resource is needed. Then often operator framework or kube builder is used, and building operators requires a lot of expertise, but then Keda helps here. So it's the universal declarative operator. So rather than using a custom operator, Keda provides a universal operator with the concept of plans built already. So it's really kind of cuts your development time a lot. So it can create operators without needing deep knowledge of a Kubernetes or coding, just by defining the lifestyle stages. And it uses Kubernetes APIs, so it's a lot easier to learn. And it has Kubernetes native management, so using kubectl and other familiar tools as well. Then the last but not the least project, which is the newest sandbox project in this session, which is Meshery. Has anyone heard of Meshery before? Okay, great. So it became a sandbox project a few months ago, early fall, essentially. So it's very fresh, very new. It's a service mesh management plane. But I do have to actually say, though, that even though Meshery is very new, it's already become the #1 project in Linux Foundation mentorship program. So there's actually very active community behind it already. So as I said, it's the service mesh management plane. So when a service mesh, which is Linkerd that I was speaking about earlier, for example, it has the control plane and the data plane. So then this adds the management plane. So what does that mean? So if you are in a situation where you have to have multiple service meshes running, so that might be due to legacy, personal preference of the team members. So if you just happen to have more than one type of service mesh, so if you have Linkerd or Istio or Kuma or whatnot in the same cluster, things might get quite difficult. So then Meshery is there to help in that situation. By being a service mesh management plane. So it's a very community-first project, and as mentioned, it's already kind of very active. So it has 15 maintainers, 300 plus contributors already, and so forth. And management plane really provides federation, integrates with backend systems. It may help perform chaos engineering, gives you deeper insight into the performance, and really a long list of things that it does. But it's just like continuing and adding more to the service mesh benefits as well. So Meshery supports over 10 different service meshes. So it has multi-mesh management, so lifecycle workload performance, configuration, patterns and practices, and chaos and filters. And as I said, it's a sandbox project, so it's not even actually the complete architecture. So it's about halfway to complete architecture. So version 1 coming eventually from Meshery. And then I'm going to start wrapping it up, but I have some learn more resources to run through as well, of course, if you're interested in those. So we went through a CNCF overview. We went through Linkerd, Keda, Flux, Keda, Meshery, and Helm, which is apparently missing from the list. And we did cover through Artifact Hub as well. So we have gone through quite many projects. It's a bit of a very hectic session sometimes, but hopefully you've learned a lot. And then learn more resources as promised. I highly recommend if you're interested in kind of like how Kubernetes is and what's the challenges and what are teams doing it, and for example, what service mesh they use, what's the most used service mesh, you can check out the CNCF survey. I incredibly highly recommend checking out all the project sites, or maybe like I like learning through YouTube, so you can just find their maintainers giving like a 45-minute deep dive about the project if you want to start using it in your projects. And then supporting your favorite project in GitHub is very important as well, because these are all open source projects where the maintainers are giving their free time. So it's really great to show your appreciation for the projects as well if you like them and using them. If you're interested in the business side of things, CNCF has really great case studies area where you can find, for example, the Babylon old Elkchirp case studies where actual real-life companies are using these in production, and then they are proudly saying that, for example, Linkerd has helped them a lot. You can check out the CNCF end user technology radar as well if you're looking for tips on what to use. And if you want to hear CNCF view into what are the predictions for future, the CNCF Technical Oversight Committee Chair, Liz Rice, does in pretty much every KubeCon this kind of predictions from the Technical Oversight Committee talk, which is really great. It kind of gives you what they think is going to be the next big thing as well. If you are a beginner and into the cloud native world, you can check out Tech World with Nana, has a lot of good material in YouTube, as well as the place where I hang out a lot. So that's CNCF YouTube, just like learning more, hearing about the maintainers and everything behind here. Highly recommend that as well. I'll be adding the links and the slides to my GitHub. There's a presentations folder there. So if you're like in the evening, you're like, damn it, I should have written down that one link. No worries, you can just hop on there and find it there. And if you're interested in the background behind maintaining an open source project, how to, start committing or start contributing to open source projects, my podcast, we interviewed Tom Kirkhope, which is one of the maintainers of Keda, and he had a very honest and frank look into how does it feel to be an open source maintainer, and what does it mean, and how does it mean working with CNCF. So highly recommend listening to that. Tom was a wonderful guest and really opened up about things. So I hope everyone has taken what they needed from this session, and hopefully everyone got inspired. And if you have any questions later on, or if you just want to see more info or learn more about CNCF or Cloud Native Landscape, you can always follow me on Twitter. I'm happy to help and talk more, of course. But that's it from my side for this talk. I think there's a Q&A and whatnot happening next. But yeah, thank you so much.
Thank you very much. So, are there any questions in the audience? No questions so far? I have a question myself. What is the kind of relationship between Keda and the cloud providers? They have their own serverless solutions. There is AWS Lambda, there is Azure Functions. So, is the idea that they will be using Keda as the underlying platform, or are
yeah, that's a good question. So Keda is not like a serverless platform per se. It helps with the auto scaling behind of it, but at the same time, so their relationship is really good. So I don't think they are going to take away, either one of them is going to take away anything away from each other. So actually, one of the creators, like kind of the company's backing Keda, is Microsoft. So I think it was Microsoft or Red Hat or something who kind of like came up with the idea. And I think Keda has 3 maintainers at the moment, and 2 of them work at Microsoft and the product groups, essentially. So they probably have a good vision as far as both of these things go and how they can actually contribute to each other and not take away anything from each other. Any other questions? Or everything was so clear? No, but it's good. If you have any later, I'm happy to talk after this presentation, or in Twitter or in LinkedIn. So always happy to chat about these topics. Yeah. Thank you.